Today, let us start with the part 4. We'll see this exercise 6.3, question number 1. If A is X such that X and it belongs to N, 45, it's given here 45. Have a look at the question on the left hand side. 45 is less than X or less than equal to X and less than or equal to 55. So whenever there is less than or equal to means we have to include 45 as well. Same here, because here is also equal to sign, so we have to include 55 as well. So all the numbers from 45 to 55. So this is written in set A. Now we'll see for B, the same set is copied over here. For the C as well, it is copied over here. So we have to find A union B. So whenever there is a union means we have to write all the elements or numbers, we can say. So which are, now we have to compare, because A and B, we have to compare this, both of them. So 45 is here there is no 45. 46 is here, so we don't have to, we have to write it only once. So this should be written only once. So the 47, then again 45 is here as well as here 48. So we have to write it only once. 49, 50 is here as well as here. We have to write it once. 51, then same for 52, we have to write it only once. 54, we have to write it only once. So all the other numbers. So what we can see, these all numbers for of the set A should be here. So we can write here, this is nothing but that is A. So because these all numbers are included in it, so that will be A. Now for the A intersection B. So for the A intersection B means whatever there is a common in both of them, we have to write it once. So now we can see 46 here, 46 here, 48 here, 48 here, 50 here, 50 here, then 52 here, 52 here, and then 54 and 54. So these all numbers should be written in A intersection B. So now what you can see, again this one, these all numbers are in set B. So we can write that is equal to B. Now for A intersection C, A and C, so 45, 45, 48, 48, 51, 51, 54 and 54. So we can see this only 4 numbers. So this is here. So for A union C, now we will see this one, we'll compare A and C. So all this one, so we don't have to just repeat this, we have to write it only once. This will write it only once. This will write it only once because it is in both the places. Again, this we are going to write it only once, and whatever rest remaining, this once, that should be written over here. So now A, this is the difference, A minus C, that is the difference of it. So in this one, whenever we have to find the difference, means what we have to see, we have to see here set of all elements of A which are not in C. So see, again I'll repeat, set of all elements of A which are not in C. So now see here, when we compare A and C, so now this is there, again this is there, this is there, now this is A minus, now this is there. So now what we can see, what number is, now we have to just concentrate on the A part, all elements of A which are not in C. So now we will see this one, what is left, this 2, 3, 4, 5, 6 and this 7 elements. So we have to write that all over here. Now here again for C minus A. C minus A means set of all elements of C which is not in A. So now we can see, again we will compare A and C. So these both are there, these both are there, these are there, this is there. So now what remains, you have to concentrate on C. So this is only the element which is not in A. So we have to just write here 57. So I have written a note over here for this one. Same follows for this one. Here I have written set of all elements of C which are not in A. For this, because it is C, you have to look at the first set. Again, here it will be set of all elements of A which is not in C. So hope this note is clear to you. So now we will go for the next one, question number 2. If x is equal to factors of 72, so x of factors of 72 means which are divisible by 72, it will be 1. Then in 2's we have 72, 3, 4, 6, 8, 9, 12. In 12 times table we have 72. Then 18, 24, 36 and 72. Then y is equal to this factors of 54. So again here the same, these are divisible by this 54 divided by this numbers we can see here, they are divisible. So here 1, 2, 3, 6, 9, 18, 27 and 54. So the factors of 48, again these are the factors of 48. So now once this is done, we have to find x, this is union y. So now we will see x and y. So these are the elements of x and these are for y. So what we can see here, this and this one, this and this 6, then 9, here, sorry, this will be 18. So what we have to do, we have to write these numbers, we are not going to repeat it. Whenever there is a union, we are just going to write it once. So what we can do, this 1, 2, 3, 4, 6, 8, 9, then 12, 18, then 24, then you write 27, then 36, then 54 and 72. This all numbers you have to write, and this you have, because these are already there in x, so you don't have to repeat it. Which whatever numbers are not there, that you are going to write it only once over here. So that is the x union y. So y intersection z. So intersection z means which is common in both of them. So when we take y and z, so what we can see, 1 is there, 2 is there, 3 is there, then 6. So rest of the numbers are not here. So we can write here 1, 2, 3 and 6. That is the y intersection z. Again here x minus y. So we have to see all the elements of x which are not in y. So x and y, x and y. So this x and y. So now this, so here will be, so what we are going to write here, 1, 2, 3 and, sorry, 4, 8, 12, 24, 36 and this one. So can you see here what was left after cancelling this? That, see again, once I'll repeat this one. So 4, 6, 12, 18, 24, 36 and 72. So we have to just see for x part. So after cancelling this means whatever is in y, that we don't have to write it. So whatever remains here, that we have to write it because it is x minus y. Now x intersection y intersection z. So we have to see in all three. So this one, 1, 2, 3, then we can see 6, and there's no other number. So we can write here 1, 2, 3 and 6. Intersection means we have to see the common in both of them. All three. So now we'll see for the question number 3. Given this is the universal set, u is equal to 1, 2, 3, 4, 5. Same thing is written here. Then this is also given, a is equal to 2 and 4. So you have to find a dash means this is the a complement. So a complement means a minus the universal set. So now what you can see here. So here again what you have to do, a minus u means you have to see all the elements which are in the universal set but not in A, because this is a complement of it. So now what you can see, this one is gone, this and this is gone. So you have to look at the universal set 1, 3 and 5, because here this is the A complement. So we have to see A minus U, but here we have to see that set of all elements which are in the universal set, but not in A. So this will be 1, 3, and 5. So now let us go for the B part. A is equal to 2, 3, 5, 6, and B is equal to 1, 3, 7, 11, 12. So you have to see C is 6 and 12. Now you have to find B union C. So B and C, you have to look at this one. So what is that? We have to write all the numbers, but we don't have to repeat it. So this is repeated, so you have to write it only once. So 1, 3, 6, 7, 11, and this you will write it only once. So this is B union C. Now B union C intersection A. So B union C, we know this is B union C, and intersection A. So we will go for this A. So what we can see here, this is going to be 3 and 3 here, 6 and 6, because you have to see which numbers are repeating. So it is going to be 3 and 6 because you have to see the intersection between this one. So 3 and 6. So now let us go for the next one. Let U is x such that x, this is all the natural numbers. So here it's given here 5 is less than or equal to x is less than or equal to 20. So this we have to, because this is equal means you have to include 5. Same here, we have to include 20. So from 5 to 20, all the elements you have to write. So that is the universal set. So there are total are 16 elements here. So we can write n of u is 16 elements. Now for x, it's given here 10 is less than x is less than 20. There is no equal to sign. So we have to skip this one and this one. So starting from 11 to 19, because again, we don't have to write here 20. So from all the elements from 11 to 19. So they are all, when you count it, it is going to be n of x, that is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 elements. Same for y, it's given 2x, all the natural number here, 2x is less than 30. So what we can do here, 2x is less than 30 means we can find this value means x is less than 15, because 2x is less than 30. So x will be less than 30 by 2, which is going to be x is going to be less than 15. So less than 15 means here what are we going to do? We are going to start from the universal set. Universal set, this is 5. So we have to start from 5 and we have to go less than 15 means the last number is going to be 14. So these total elements are, that is n of y is 10 elements. Now you have to find n of x union y. Now you got all the value, this one. So x and y. So this is x and this is y. So n of x union y will be n of x, because this is n of x union y. So that is there is a formula for that n of x plus n of y minus n of x intersection y. So n of x means this is, we already know this is 9. So we'll write here 9. N of y means already we found that n of y is 10. So we'll write here 10. And n of x intersection y. So intersection y means in both of them, can we see here intersection y? So x and y. So how many we have here? This is for x and this is for y. So now we will see the elements over here. Where is it intersection? This will start from 11. So we'll cut this 11, 12, 13, and this one 14. Intersection means we have to just take common. So how many elements are here? So you can write here separately n of x intersection y. That is going to be how many elements we have? That is the 4 elements. Hope you got this one. We have to just compare this x and y. Intersection means you have to just take the common one. So that is going to be 4 elements. So here you are going to write here minus 4. So this is going to be 19 minus 4, which is going to be 15 elements. Now the next, now let us see how to find out this one, n of x intersection y. So here intersection y means we have to see that x intersection y. So this is x and this is y. Sorry, this one is y. So here we have to see the elements which are common. So now we can see here 11, 12, 13 and 14. 11, 12, 13 and 14, which are in both the sets. So we have to write that 11, 12, 13, 14, which are the four elements. So now here they said n of x complement. So n of x complement means this is n of x complement, n of, so we have to see set of all elements. Now this is the rule given, that is the set of all elements which are in the universal set but not in X. So now we have to see X and the universal set. So now we will, this and this gets cancelled, 12, 13, then 14, 15, 16, then 17, 18 and 19. So now what is remaining here? 1, 2, 3, 4, 5, 6 and this 20. So there are 7 elements remaining. So we can say n of x complement, that is going to be 7 elements, because set of all elements which are in the universal set but not in X. Now here we have to find out n of x union y, and that is the complementary fit. So n of x union, first we have to see n of x union y, that is we have already done, that is the 15. X union y we already found out here, which is 15 elements, and now we want n of x union y. This is the complement of it, so that will be n of u minus n of x union y. So you know the n of y we already did here, which is 16, so that will be 16 minus n of x union y. X union y we already got this as 15, so 16 minus 15, which is going to be 1. Now the next one, n of x minus y. So here we have, what we have to do, we have to remove, we can say this is in a simple way, that 11, 12, 13, 14 we have to remove from x. So what will remain is 15, 16, 17, 18, 19. You can just have a look, because I have to scroll it up and down. So I have just written in these words. So that is going to be 5 elements. So they said also verify that n of x union y is equal to n of x plus n of y minus n of x intersection y. So this we have to verify. So now this is the left hand side, and this whole part is in the right hand side. So we'll start with the left hand side. So left hand side is n of x union y, and we already done n of x union y over here, which is going to, this is given as 15 elements here. So that is 15. The RHS is this part. So n of x plus n of y minus n of x intersection y, this all we have solved. N of x is 9. You can just scroll and say n of y is 10 elements, and n minus this is n of x intersection y, that is 4 elements. So when you solve this, we get 15. So what we can see, LHS and the RHS both is same. So LHS is equal to RHS. So we can say n of whatever they asked to verify this part, that is the same. So by this one we have completed today's work. Do like and subscribe to my channel so you get the notification of other parts. Thank you.